All right, Gretchen, so let's talk about concentration for a second. Hey. Right, so if we talk about concentration, when you talk about chemical concentration, it is actually a concept that you are completely familiar with, because all of you at some point have created a solution at home, okay? So if you think about cool drinks that you mix, like Oros, or what are other ones that you mix at home? I don't know. But if you're mixing cool drinks, then you know about the concept of concentration, because you understand the idea that we're creating a solution, okay? And that solution has two parts. It has a solute and it has a solvent. The solute is the stuff you're putting into the solvent, okay? So if you're making Oros, the solute would be the water, and the solvent would be the water, and then the solute would be the actual stuff from the Oros bottle, the concentrated stuff, okay? And we know that the more Oros we add to the water, the stronger the concentration of our overall solution. So you can hear that I've just spoken about three very particular words here: the word solution, the word solvent, and the word solute. Okay, so those three ideas are quite important. Now, I want you to write this down as the definition for concentration. Are you ready? So, we can define concentration as the concentration of a solution, the concentration of a solution is shown as the quantity of dissolved solute in moles per decimeter cubed of solution. Moles per decimeters cubed of solution. I'm going to go right from the top. The concentration of a solution is shown as the quantity of dissolved solute in moles per decimeter cubed, like I've just written on the board, of solution. When we talk about concentration, we can calculate it by saying that concentration is equal to number of moles divided by volume. Okay? And when we use this particular equation, this refers to the concentration. Alright? Concentration is C. Concentration is measured in something called moles per decimeter cubed. Okay? I'll show you why in a second. Over here, N refers to moles. Okay? Obviously, moles are measured in that unit. And V is volume. And volume is measured in decimeters cubed. And that's why concentration is moles over decimeters cubed. So you'll see it's moles over decimeters cubed. And then if I want to write that, we take the decimeters cubed to the top of the fraction. But if we take something to the top of the fraction, then the exponent must become negative. Do you guys know that? Are you sure? You know, like if you have 1 over x, it can be written as x to the minus 1. Yes? So in the same way, you can have mole and per decimeter but to the minus 3. Okay? Good stuff. Let's pause for a second. There is an alternative way to calculate concentration by using other calculations that we've learned previously. So we know that number of moles is equal to mass over molar mass, yes? We know that from our mole calculations, we did like a million of those. Okay. So we can replace the n with little m over big M. Okay. So instead of writing n, we can say concentration is equal to little m over mv. Because I've replaced the n with the m and the big M. Okay. And so we end up with an equation where we still have this as the concentration, but now we have the mass, the molar mass, and the volume. So it all depends on the information that you've been given for a particular question. Okay. Okay, so when we look at the example, it's very, very important that we write down a list of what's been given to us. So I have my concentration, which is what I'm looking for. I have my number of moles, which has been given to me as 0.2 moles. And I have my volume. Now the problem with the volume is that the volume is in the wrong unit. Do you notice that? The volume is in centimeters cubed. What must volume be measured in for concentration? Decimeters cubed. Which means, if I have my 250 centimeters cubed, the question is, how do I convert that to decimeters cubed? Well, right at the beginning of the lesson, we spoke about the fact that if there was a 10 difference between the two units, if I scale that up to a volume measurement, then it becomes 1,000 difference. Do you remember that? We went from centimeters to millimeters, and the difference there in terms of the unit was 1,000. Okay? So, what you need to realize is that there is an actual fact. 1,000 centimeters cubed is the same as 1 decimeter cubed. Because, like I mentioned, millimeters, centimeters, decimeters, meters, those units as just a distance measurement. The difference here is, or the conversion is, by 10. Yes? So if you have 10 by 10 by 10, you end up with 1,000. So that means that to convert the volume to decimeters cubed, I must divide by 1,000, yes, to get decimeters. Are you okay, Laika? I can see your face is not happy with that. I get 0.25 decimeters cubed as my volume measurement. Are you right with that? Okay, now I'm going to plug this into an equation. So the appropriate formula is concentration is number of moles over volume. The number of moles is 0.2. The volume here is 0.25, which means I end up with an answer of, I will wait while you plug that into your calculator and give me a bit of an answer. Sorry?
0.8.
0.8. And the unit here is moles per decimeter cubed. Moles per decimeter cubed. All right. Let's pause there.